Friends, welcome back with another video. In this video we're going to see how do we derive an expression for lens makers formula from the chapter 9 view optics class 12. Okay, so first if we see the rough diagram for this is we have to consider a lens. Lens we can name like A, B, C, D. There's the principal axis. There is a principal axis which is passing through it. If we consider O at some point, the incident ray, the refracted ray, arrow marks are very important for the derivations in ray optics. Wherever they involves a mirror or lens, in using the incident ray, reflected ray, refracted ray, there must be an arrow mark. And if you don't draw an arrow mark, you're gonna lose a mark. Okay, so this is the rough diagram, and very important formula we have to remember for the derivation is n2 by v minus n1 by u is equal to n2 minus n1 by r. So this is n1, this is also n1, this is n2. Okay, this is the important formula we're going to remember for this. So let's start the derivation. In this derivation, there we can see this image formation takes place in two steps. Okay, that is the refraction taking place at the surface ABC and the refraction taking place at the surface ADC. So we have to split up this lens into the surfaces, two surfaces, to derive this expression. So first we have to take the surface A, B, C. Okay, so if we take the surface A, B and C, we have to draw a principal axis. If we draw principal axis, there comes an object O. If we take an object O, somewhere here it will there is, okay, I'm just drawing an incident ray. So this is the normal, which is passing through the center of curvature. C1 will say here. So therefore radius of curvature is R1 and image distance is U. Okay, then somewhere here it forms an image. Okay, image is formed here. This is angle of incidence and angle of refraction. This is the refracted ray. Image formed here is I dash. Therefore it is V1 be the image distance. Okay, so first what we have taken the refraction for the refraction at surface ABC. At the surface ABC, if we say O is the object, I dash is the image form. So as I've told before, the important formula is n2 by v minus n1 by u is equal to n2 minus n1 by r. This is a very important formula. Just by this we are going to derive the lens maker formula. Okay, so using that, n2 by v is the image distance. Image distance is v1 here. So n2 by v1 minus n1 by u is the object distance, which is equal to n2 minus n1 by r1. Okay, so this is the equation number 1. Now for the second surface we have to take. If we take for the second surface, it is ADC. Okay, ADC. Now ADC, if we take the same, we have to draw a principal axis. First is principal axis. After that, here I dash is the virtual image. Okay, I dash is already formed, which is of distance. Okay, I dash is already formed, which is of V1. Okay, so this V1 is going to be now object distance. So I dash is the virtual image. The center of curvature is if it is here, this is going to be the normal. So R2 is going to be now the radius of curvature. Then the refracted ray is going to be like this. Okay, the image formation takes place at the same side of the lens where the virtual object is there. So this is going to be high. So it is V is the image distance. Okay, we are clear with V1 object distance, V image distance, R2 is the radius of curvature, and N2 N1. Okay, now for the refraction at the surface ADC, for the refraction at the surface of ADC. at the surface ADC. I dash is the virtual object and I is the image font. Okay, image. Now n2, now it's going to be n1 by v minus n2 by v1. V1 is the object distance, v is the image distance. So n1 minus n2 by r2. The first equation, if we see, the right hand side is in the form of n2 minus n1. So this we interchange. If we interchange, n1 by v minus n2 by v1 is equal to n2 minus n1. So minus, if we take out common, it is going to be n2 minus n1 by r2. So n1 by v minus n2 by v1. This minus we are going to take to the denominator, n2 minus n1 by minus r2. This is going to be the second equation. Now we have to add up both the equation. Add equation 1 and 2. If we add equation 1 and 2, equation 1 is n2 by v1 minus n1 by u plus n1 by v minus n2 by v1, which is equal to n2 minus n1 by r1 plus n2 minus n1 by minus r2. Okay. Now n2 by v1, n2 by v1 both get cancelled. Now n1 is common in both, so I am taking it common into 1 by v minus 1 by u. Okay, 1 by v I have taken first and 1 by u I have taken the next. Okay, now which is equal to, now here n2 minus n1 is common in both, so I am taking it common. n2 minus n1, if I take common, 1 by r1, this minus comes here, so minus of 1 by r2. Okay, this we are going to obtain. This n1 we take to the other side. If we take to the other side, 1 by v minus 1 by u is equal to n2 by n1 minus n1 by n1. For the individual term, it gets divided into 1 by r1 minus 1 by r2. Now 1 by v minus 1 by u is equal to n2 by n1, we can write as n2 1 minus, this gets cancelled, so 1 by r1 minus 1 by r2. Okay, here suppose if the object is at infinity, if the object is placed at infinity, then the image will be formed at focus. Okay, this we know. So therefore we are imposing a condition on this to get a lens maker's formula. So the object distance is at infinity. If the object distance is at infinity, the image distance will be at focus. Okay, at focus. So therefore the equation is going to be 1 by f minus 1 by infinity. 1 by infinity is going to be 0, which is equal to n2 1 minus 1 into 1 by r1 minus 1 by r2. Now 1 by f is equal to n2 1 minus 1 into 1 by r1 minus 1 by r2. This is the lens maker's formula. Thank you for watching this video.